What's the point of scientific notation? Well, here's some examples of numbers that are written in scientific notation. If we were to write each number as is, we'd have to write a whole lot of digits, and that's just simply inconvenient for us. Thus, one of our uses of scientific notation is for convenience and brevity. Likewise, of these two numbers, which is bigger and which is smaller? Looking at it, it's hard to tell because, yes, the 8 is bigger than the 7, but it's like, how many more zeros does each one have? We just write it with scientific notation and it becomes abundantly clear that this blue number is almost 10 times as big as this red number. Thus, scientific notation also gives us a clear basis of comparison as to which numbers are bigger or smaller and by how much. Next question is to determine both the coefficient and the amount of significant figures this number has. So even though 0.58 appears to be the coefficient as it's right in front of the 10 to the negative 7, it's not between 1 and 9.999. For this reason, this number isn't even written in scientific notation. So we need to write it in scientific notation and then determine these things below. So you find the coefficient and it's 5.8. It's the number between 1 and 9.999. And from that, how many significant figures does this have? Well, it's ruled that the significant figures of a number in scientific notation are solely determined by the coefficient. Thus, this number has two significant figures. Convert 0.00050006 into scientific notation with correct number of significant figures. First, let's derive our coefficient by moving the decimal place to right after the first non-zero digit. We get 5.0006. As we can see, we had to move the decimal to the right 4 times, so we multiply our coefficient by 10 to the negative 4. And that's our answer, and it has 5 significant figures.